Water. It's one of our most precious resources. However, our supplies are limited. More than 1 billion people in the world don't have access to clean water. In places like the sub-Saharan Africa, people, especially women and girls, walk miles to gather water from streams and ponds that are full of waterborne diseases that's making them and their families sick. The World Health Organization says that every year, more than 3.4 million people die as a result of water-related diseases, making it the leading cause of death around the world. And most of the victims are young children. So by the end of this video, 32 children will have died. But it doesn't have to be this way. The world we're living in is changing. Technology is revolutionizing everything. But is there really an answer to making polluted air breathable again? Or filthy water safe to drink? Well, the answer lays in the filter technology based on nanoparticles. Nanoparticles are particles that have diameters between 1 and 100 nanometers. What makes them so special is that they exhibit size-related properties significantly different from those of either fine particles or bulk materials. Filtration is one of the best techniques to remove impurities from liquid. One of the best materials used in the filtration industry is the use of activated carbon. Activated carbon is a very powerful adsorbent. It's a highly porous substance with large surface areas reaching almost 3,000 meters squared per gram. A bed of activated carbon is used to adsorb pollutants and sediments, plus removes chlorine, heavy metals, microorganisms and odors from contaminated fluids. Let's take a look at a very simplified diagram of an activated carbon nanoparticle. As you can see, it's very porous. So how does adsorption work? First, the substance to be removed adsorbs to the exterior of the carbon surface. Then, the substance moves into the carbon interior pores, and eventually the substance adsorbs to the interior walls of the carbon pores. Adsorption onto activated carbon can be done in two ways: physically and chemically. Organic matters in water can be trapped inside an activated carbon filter via physical adsorption. The adsorption depends on a few factors, such as the concentration of the contaminant, water pH, temperature, and the contacting time between the activated carbon and water. Physical adsorption has been shown to work best at low temperatures and at pHs around 7 to 7.5. One way in which activated carbon is used in chemical adsorption is its role as a reducing agent in removing chlorine. The removal mechanism of chlorine is accomplished by reducing chlorine to non-oxidative chlorine by activated carbon. Another important thing worth mentioning about activated carbon is what it's made from. Today, most of the activated carbon filters we use are made from biomass, such as coconut shells, peanut shells, and wood products. Some are even made from petroleum coke and coal. However, there is growing research into producing activated carbon from agricultural waste, such as rice straw, sugar beet, and sugarcane bagasse, all of which have become critical environmental issues due to growing agricultural demand. Now, let's end this video by seeing a practical device that uses activated carbon in filtration. Michael Pritchard, an American engineer and water treatment expert, used the particle properties of activated carbon to develop a portable water purification system device which filters out objects that are larger than 15 nanometers. This device can filter the tuberculosis bacteria, which has a diameter of 200 nanometers, as well as the poliovirus, which has a diameter of only 25 nanometers. To put it to the test, Pritchard, in his TED Talk, brings out a water tank and fills it with pond water, runoff from a sewage plant farm, and feces from rabbits and horses in an attempt to model the type of water that people in disaster-stricken areas and third world rural communities drink from. He then shows the audience how to use the device. and drinks sterile, clean drinking water. But let's not forget that this is just one example of how nanotechnology is changing our world. Nanoparticles infiltration technology is allowing us to envision a cleaner, healthier and happier world for everyone.